Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. So, if we are talking about our last lecture, we have completed electromagnetic induction. Two major topics of magnetism we have completed till now. Okay. And now we are into the section of alternating current. In the last lecture, if you have watched the video, you can feel the connection, because in last lecture, in the last portion, I told you about an AC generator. There we have talked a little bit about alternating current. We have talked only about that alternating current keep changing its direction with in a periodic manner. This is called as alternating current. So till now what we were studying, what was that current? That current is called as direct current. In the basic classes also you understand the difference between alternating current and direct current. So direct current always flow into the same direction, in a single direction, but alternating current flows in both the directions. Correct? Let's see, our voice is clear to everyone. Let's see, our voice is very nice. Just a minute. Hello. Now I guess it is fine. Now I guess it is fine. Okay. So we were discussing about last lecture about AC generator. So what is the work of AC generator? If the work of AC generator is to generate an alternating source. It is to generate an alternating source, and from that source an alternating current will be generating. So this topic is all about the concept of alternating current. So let's begin the topic without wasting any further time. Okay, I hope that you are excited to learn something new. So be ready with your pen and paper, and let's start the topic. Alternating current. If I will tell you about the basic idea from where you can have the idea of alternating current, why I am saying that it is keep switching its direction. Okay, if you want to see the real proof that in our households also we are having alternating current, it is not the direct current that we are having in our houses. No, we are having alternating current. And the best example you can understand, take a camera at the tube light, okay, and watch the tube light in very slow motion. When from naked eye it is impossible to check to match the frequency at which it is changing its direction. But when you are watching from a camera, slow motion camera, then you will be able to observe that it is not continuously glowing. Okay, sometimes it is getting dimmer also, the tube light that is there, but the frequency is so fast, so from your naked eyes, normal eyes, it is impossible to match that. So it is given just about the idea. Do a slow motion in your video and just try to watch why that is getting dimmer and lighter, dimmer and lighter, dimmer and lighter, because of alternating current is constantly changing its direction. So due to that fraction of seconds, this phenomena is occurring. Okay, so in our houses also we are having what? Alternating current. Is it clear? Fine. So for understanding alternating current, what is the difference? It is bestly represented by, I told you what was the equation in last class also for alternating source. Alternating source, if you remember the equation that I have given you, was E is equals to E naught sine of omega t, and current got from here I naught sine of omega t. So I can say the alternating sources are the function of sine function, are sinusoidal function. If I am talking about direct current, see, here is the direct current. Here it is given the definition of alternating current. Here it is given direct current. Now what is direct current? Direct current, I can say in the complete time period it is moving only in a single direction. That is what? Positive direction. That is what? Positive direction. But if I am talking about alternating current, now notice what is happening with alternating current. In this section, plus of t by 2 section, it is happening what? It is getting positive. In the next section, it is getting again negative. Again in the next section, it will become positive. So constantly with time, what is happening? Current is changing its direction, and if this kind of current is present, this kind of current is called as what? Alternating current. It is called as alternating. About equations also I have told you in the last class. This is a DC source, our normal battery that we have understood for the complete 3-4 chapters. Okay, that was the source of DC current. But what about the source of AC current? How it is represented? This is the source of AC current. Equation is this, E naught sine of omega t, and it is represented by this sign. Okay, it is represented by this sign, and from this kind of source alternating current will be emitting. Clear? These were some basic things how you can understand. See, there can be other possible variations also for alternating current. It is not needed. It will be always only sinusoidal function. This kind of curves here you can see. If I will explain you, if I will tell you, in this portion it is positive, in this portion negative, in this portion again positive, in this portion again negative. If I am talking about this one, this will be positive, this one will be negative. Here this will be positive, this will be negative. So this kind of positive negative oscillations will be there. So all these are the examples of, very good examples of alternating current, because current is constantly changing with a period of time. There is a basic question, try to answer this question. Okay, try to answer this question. Variation of current with time for 4 types of generator are shown in the figure. Which amongst them can be called as alternating current? Here are given 4 options. Tell me which of the options are alternating current. Option A, only A. Option B, A and D. Option C, A, B, C, D. And option D, A and B. What do you think? What will be happening? So should we analyze one by one? Let's see. Tell me about section A. What you can say about it? Is it alternating current or no? See, this is negative, this is positive. Again, this is negative. So I can say this is an alternating current. No problem. Square wave. We have already seen it. This is positive. This one is negative. Again, it is also an alternating current. If I am watching at this, again, this portion is positive. This portion is negative. Again, it is an alternating current. And here also vice versa. I can say it is also an alternating current. So which option is coming correct? I can say simply that option C is coming correct. All the options A, B, C, D are actually what? Alternating current. All the options are what? Alternating current. Is it clear? So all the options I can say are alternating current, because all of them are changing their directions. Now before entering into the core chapter, we have to understand 2 very important terms. What are the 2 important terms? 2 important terms are, first is average current. How to find the average? We have already studied about both of the things. Second one is RMS current. Now what is RMS current? Root mean square. Root mean square. And I can say that already you are familiar with this term in KTG. In KTG also we have calculated what? RMS velocity. There we have calculated RMS velocity. Now what is the full form? Root mean square. And if I have to solve it, I have told the trick that read it in opposite manner, you will be easily solving the RMS. We'll be getting to that, but firstly we have to tackle out how to find the average values, how to find the average value and what the formula. Before also I have told you what is the formula of any kind of average. See, if any function is there, let's see our pen. See, let's suppose current is given as some function of time. Let's suppose current is given as some function of time, and if I want to calculate the average of this current, I will be doing what? Integration of that function with respect to dt from initial time t1 to t2 divided by integration of dt. This will be the general equation of average. Any kind of average, if you want to calculate heat average, any kind of average if you want to calculate, this formula will be always valid. This is in general formula for calculating average. For calculating what? Average. Now there are different interpretations. How I will interpret this also as, see, what you can say about this term. If you notice, in numerator what I have written? F of t dt. Or further, if I want to write it, I can write this also as integration of I t dt divided by integration of dt. Correct? And integration of dt is going to give you t, and if the limits are t1 to t2, you will be writing t2 minus t1. I hope that this will be clear to everyone. But what I am trying to tell you, that understand what is this curve? This is I curve, okay, and this is what? T curve. This is one is I, this one is T. So if I will ask you, tell me area under this curve. Area can be written as what? Integration of y dx. This is the general equation. At y what is there? Current. At x what is there? Time. So can you say the area under the curve is going to give me what? I dt. And it is a universal thing. Always remember that 2 things for any graph you should be remembering. One is slope, that is dy by dx, and second one is I dt. Okay, these 2 things are very important. You have to remember. So this is going to give you the area under the curve. So can I say this formula is also, this is fine from integration from time t1 to t2, from t1 to t2. I can also write this I dt as area under IT graph divided by t2 minus of t1. Can't I say? So always remember, for finding average, this will be the complete formula. This will be the complete form. Now it depends how much your math is good, you will be able to solve this. Anyways, I will tell you some short tricks also to directly remember the result, that will be helpful for physics, but still good level of questions will be applying some maths. Okay, I'm already playing. See, let's have a question, and this question is going to explain in much better way how to find the average values. How to find the average values. Let's start solving. What is the function that is given, students? Current is given as I is given as 3t square. I is equals to 3t square. Find the average current in 2 seconds. You have to calculate what is the average current in 2 seconds, in the first 2 seconds. How will be calculating? I have told you that average current equation will be integration of I dt divided by integration of dt, and limits will be 0 to 2, 0 to 2. Now write what is the current with variation with time? 3t square dt integration dt integration 0 to 2, 0 to 2. Now here what will be the limits of integration? Here it will become 3, integration of t square will become t cube divided by 3, and I can say this 3 is going to be cancel out. Here it will be left only t cube, and here it will be what? 2. Of course the integration of dt is going to be t, and limits when you will be putting, it will become only 2, and here also put the limits 0 to 2. 0 to 2, when we will be putting the limits, it will be coming 8 by 2 minus of 0. Can I say finally answer will be coming equals to, that is 4 ampere. Which option is coming correct? Actually C option is coming correct. 4 ampere will be the correct answer. Is it clear? I hope that this is clear to all of you, how I have calculated the average current. Now see, if the question is asking you for full cycle, for one full cycle, if the question is asking you calculate what is the average current, you will be going with the same method. But I will tell you in general thing, I have told you, I will tell you some tricks that you have to remember, then you can easily calculate the average values. See, what I want to tell you, that if in full cycle you want to calculate what is the average current, how you will be calculating? See, what I have told you about the relation, I dt is fine. This is the relation that I have told you, I dt divided by integration of dt, and I have told you what is I dt, it is area under the curve. So if I am talking about full circle, notice here, let's see the example of sinusoidal curve only. If I am asking you the average current for full cycle, what I can say? I will say average current will be equals to total area from 0 to time period t divided by t minus 0, that is integration of time period. Now if I will be asking you that tell me what is the net area from 0 to time period t, what will be saying? Sir, this positive area and this negative area. And can I say both? This is plus a, if this is plus a, can I say this is minus a? So if I will asking you total area, what will be calling about total area? Cannot I say that it is going to be equals to 0? Yes or no? Because the net area is 0, I can say what about the average current? Average current is also going to be 0. Now you can cross check it for everyone. From only I am asking you for one time period. For one time period, again plus a minus a cancel, again plus a minus a cancel, plus a minus a cancel. So always remember, for our complete cycle, the average value that you will be getting is equals to always 0 in a complete full cycle. That is what we have to remember. Okay, very important result, I will say. Okay, so this thing also I have explained you in the last lecture, that this is the source of alternating EMF. Okay, so full cycle alternating current, you will be having average current as 0. Now if you want, you can calculate it as well. How you will be calculating? Let's suppose the equation is given to you is I is equals to, let's calculate it. Anyways, we know the result, but we want to verify the result also. So let's calculate. What will be saying? Average current is equals to I naught sine of omega t dt integration divided by integration of dt from time 0 to time period t, 0 to time period t. Correct? Now, and what is t also? What is t? This is complete one time period. If I have to write t can be written as 2 pi by omega. I hope that this will be clear to you. Correct. Now I can say that I naught is a constant. Take it out of integration. Integration of sine omega t. Integration of sine omega t, students, it is going to give you cos of omega t, and there will be a negative sign also. And in divided by it is a denominator, that is going to give you t. Now put the limits 0 to 2 pi by omega. If you are putting the limits, what you will be getting? Cos of omega into 2 pi by omega, it will be simply 2 pi minus of cos of 0. Correct? Cos of 0. Now tell me, what is the value of cos of 2 pi? What is the value of cos of 2 pi? That means cos of 360 degree. What is the value of cos 0? It is equals to 1. So I will say it is equals to 1, and here also it is also equals to 1. That is 1 cancel, and what is the final answer that is you are going to get? That is equals to 0, and hence it is again proved that the final in full cycle average value of current is going to be equals to 0. Simple. So we have verified that also. The result in the notes, it is completely available. Here you can say cos 0 minus cos of 2 pi. Now the next thing, next important thing, I have told you that we are going to understand two important terms before entering into the core chapter. Now the next thing is RMS current. What is the next thing? We are going to study about RMS current. Now what is RMS current? Already you know about it. About this in more depth we are going to say, but as of now we are just watching it from the mathematical perspective. That what will be the RMS value of these things. See how I can define RMS value. Firstly, write the full form. RMS value is defined as root mean square, and it is not only defined for current, it is defined universally. It is defined for everything. Like RMS velocity also we have calculated. If I will ask you, tell me what is the value, what is the RMS value, how you will be solving the question. Firstly, what you will be doing, go in the reverse manner. Firstly, do, if let's suppose current is given as I, or it is given as I. Firstly, do square. What you will be doing? Square. Then take the mean is the representation for this, and finally take the square root. If you are doing these three things, this will going to give you the RMS value. This is going to give you what? The RMS value. Now in this also I will tell you some important things that of course you have to remember, but let's say before understanding those things, let's try to derive the values. Because in board exam you cannot directly write the things, so let's derive it. So you also continue with me. Okay, let's see how we can derive. We want to calculate RMS current, and what is the equation of current that is given? I is equals to I naught sine of omega t. Fine. What is the first step, students? What is the first step? I will write S. S is the squaring is the first step. Do the square. If you are doing the square, what you will be getting? Sine I naught square sine square omega t. Clear till here? Any doubt? No. Now next step. Now what you will be doing? Taking the mean. So I will write here MS. Taking the mean means what? Remember last time average and mean are nothing but same thing. You will be doing integration of I dt. Take I naught square common. Integration sine square omega t dt divided by integration dt. This is what you are going to get. And we are integrating out for a complete time period. Okay, fine. So this integration is going to give you nothing but t. That's why I am writing it inside. It is equals to t. Now the major integration is for sine square omega t. And if anyone have the basic idea of integration, we will replace this sine square omega t. If you know, there is a term 1 minus cos of 2 theta is equals to sine square 2 sine square theta. This is a trigonometric identity. So from here I can replace sine square omega t is equals to 1 minus cos of 2 omega t divided by 2. Correct? So now replace it. Go step by step. No problem, no hurry. So I'm going to replace it, and I will be taking this 2 here so that there will be no problem in the integration, and I will be writing 1 minus cos of 2 omega t. This is what I have to integrate, and the limits of integration is 0 to time period t, capital T. Now integrate it. Right? I naught square divided by 2t. Integration for 1 will be t minus integration for cos omega t will be sine of omega t, sine of, sorry, 2 omega t, I should write it as 2 omega t, sine of 2 omega t from 0 to time period t. Now put the limits. On it. So when you are putting the limits, what you will be writing? Firstly, you will be writing t, that is equals to 2 pi by omega minus sine of here what you will be doing? You will be writing t is equal to capital T, that is 2 pi by omega. That means I can say nothing but it is equals to 4 pi. Clear? Now put 0. When I am putting 0, it will be automatically 0, and here it will become sine of 0. Now what is sine of 0? This complete term is going to be 0. Sine of 4 pi is also 0. That means here what is left? Only I can say t. And in denominator also, here it is also t. That means this t is going to be cancelled out, and what I can say? IMS. Till now we have not reached to the final result. We have only written IMS is equal to I naught square divided by 2. I naught square divided by 2. Now let's move to the next page. Let's write the final result here. We have calculated IMS is equals to I naught square by 2. That means now what is the final step? We have to take under root, that will be equals to, when you are taking under root here, it will be I naught divided by root 2, and this is a very important result that you have to remember. What is RMS current? RMS current is equals to I naught by root 2, and this I naught is called as what? This is called as peak current, or also sometimes represented as current amplitude. Also sometimes represented as current amplitude. Is it clear to you? It is also represented as current amplitude. This was the complete derivation that you have to understand. Okay, this was the complete derivation, and this is very important. Even it is valid for EMF also. It is not only for current. If someone asks you, tell me ERMS, then what will be writing? It will be equals to E naught divided by root 2. E naught divided by root 2. Okay. So please remember it. It is very important result. Okay, you cannot afford to forget this result. Now some very important tricks that I have asked you, that I am going to tell you, so that this calculations will become very easy. It is only for competitive exam. Don't try this in your board exam. See, these two values already we have derived. These two values, remember, for half cycle what is the average value? For both it will be same kind of value, only you can replace I naught divided by E naught. So that is the only change that will be getting. Otherwise the half cycle result is same. One more very important thing I am telling you, that the average value of sine square omega t is equals to average value of cos square omega t for complete time period is equals to half. This is a very important result. Very important result. Directly remember it. Very fastly you can find your answers. Why I am saying that? We have remembered for sine omega t and cos omega t, what was the average current coming for total cycle? It was coming equals to 0. Reason? You remember that plus area minus area, both of them were cutting out each other. That's why the net area that was coming was 0. But when I am talking about square in net area will not be equals to 0, and the value that you will be getting is half. Okay, directly remember this. This is a very useful result that is going to help you. So if let's derive from this value also our value was coming correct or not. What was the general current equation? What was the current equation? I was equals to I naught sine of omega t. Correct. What was the first step? Doing square. Do the square. Yes, it will be equals to I naught square sine square omega t. What was the second step? Taking average. Take the average. I naught square will be as it is, average of sine square omega t. And what I have told you, that average value of sine square omega t is equals to nothing but half. It is nothing but equals to half. That means I can write this as I naught square by 2, and here in the final step I will be taking root. Take the root. When I am taking the root, final result will be coming I naught divided by root 2. Exactly our value is correct. Exactly our value is correct. That means we have did it correct, and that is a very important result. As much as star you can apply it. It will be solving the questions in just fraction of seconds. Okay, so very good. See, about our household, if I am talking, I have already told you that we are not having DC current, we are having what actually AC current. And what is the peak value? Peak value that we get is 220 volt, and the frequency that we get is 50 hertz. Is 50 hertz in India. Yesterday I have told a question that what is the frequency of current that we have in America? In USA, what is the frequency of current? There is very slight difference, but still there is some difference. The student who will be telling me, they will receive a gift voucher from us. Okay, so comment down in the comment section. You cannot Google it. We will be catching you. Fine. So what is the meaning of, now let's understand, try to understand the significance of RMS value. What is this RMS value is trying to tell you? RMS value is kind of equivalent value of a DC circuit. Okay, not clear. Let's understand here. Okay, see, household circuit, I have told you already that it is 220 volt, that is the peak EMF that is coming, and 50 hertz is what the frequency. Okay, so if you have to calculate the peak EMF or anything, you can do what? RMS value is equals to E naught by root 2. That means if you have to calculate E naught, that means the peak EMF that you will be getting, that means you have to do ERMS into root 2. ERMS into root 2, and if ERMS is given as 220, ERMS you will be getting E naught is equals to when you will be solving it, it will be coming nearly 311 volt. So this is the equivalent of voltage in RMS current circuit. One more very important point that is mentioned here. Most of the time students get confused, sir, what we have to take. Now we are having peak EMF also, RMS EMF also, and average EMF also. So until unless nothing is mentioned, we always have to take it in this chapter as RMS value. What will be, if problem states only E, that means you cannot, it is not E naught, it is not average. Then it is always considered as ERMS. If nothing is mentioned, only EMF is written in this chapter, always you have to take it as ERMS, always. If it is mentioned, then fine. If it is an equation, that means E naught sine of omega t, that means it is very clear that the first term that you will be getting is E naught. Okay, so if I am talking about the significance of RMS circuit, it is given as RMS value of an AC can be defined as a DC value which produces the same heat in a resistance which the AC produces by that resistor in the same duration. If I am taking an AC circuit, and I am taking one side a DC circuit, the net heat that is produced in an DC circuit should be equivalent to the heat that is produced in the AC circuit. That value of current is called as RMS current. Resistance will be same, time will be same, correct? Then only change will be there for the RMS value. Okay, so it is also defined as RMS is the effective DC value of a given AC circuit. It is the effective DC value because and even you cannot calculate this AC current in terms of that ammeter or voltmeter. Those things are not used directly. They will not show you any kind of reflection because continuously the polarity is getting changed for alternating current. So there is some different kind of devices that are introduced, that is hot wire ammeter and hot wire voltmeter. These kind of the things, instruments that we usually use to calculate this RMS values. This line is very important. Always remember, if you are writing this in your exam, you can have a very good marks. That RMS current is the effective DC value of any given AC circuit. For any given AC circuit, if someone asks you, tell me the effective DC value for this, because we are habituated to calculate anything in DC value. See, because DC value is much easier and clear to us to understand. I hope that this will be you can relate it with, because from the childhood classes we are understanding about DC, and now there is an AC that is continuously changing its direction. So still we want to some equivalent value that is in DC circuit. That's why we have introduced the term RMS. Okay, I hope that this will be clear. Here is an important point, that hot wire ammeter and hot wire voltmeter are used to measure AC. They measure RMS value of current and EMF. Okay, now here is a question. Let's try to solve it. Okay, firstly read the question. What is the question is saying? This question we will be clearing a lot of basic doubts that we will be having. If the voltage of a source in an AC circuit is represented by the equation, okay, equation is given as this much, 220. And what is the general equation? That also let's write E naught sine of omega t. That means if I am comparing this, I can say I got one thing, that E naught is equals to 220 root 2. Calculate the peak value of current if the net resistance of the circuit is 220 ohm. Take okay. You have to calculate what is the peak value of current. Peak value of current means what? I've told you that you have to calculate I naught. For calculating I naught, what you can do? I can say this is E naught, that is already given. E naught is already given. That means what you can do for I naught can be written as E naught divided by R. I naught can be written as E naught divided by R. So I can say 220 root 2 divided by, what is the resistance that you are taking? That is also equals to 220. Cancel. What is the answer? That is root 2 ampere. And root 2 ampere you can take as 1.4. That means I can say option C is coming correct. 1.4. I guess answer will be option C, 1.4. Answer is option C, that is 1.4. Simple question. This could be even a good question can be asked, that tell me what about the RMS values, RMS, how much RMS current will be there. Then that relation will be coming into use. I RMS is equals to I naught divided by root 2. Correct now? But it have asked you for a very simple thing. All these values already I have told you, that average value of sine omega t, average value of cos omega t is 0, 0. Average value of sine square omega t, cos square omega t is half for a complete full cycle. Please remember this value. This is very useful result. Here is a good question. Calculate the RMS value of this current. Very interesting, and you can use the result that you know about it. Okay, let's try to calculate. What is the first step? RMS you want to calculate. What is the first step, students? Firstly you have to do square. What you have to do? Square it. What you will be writing? I naught square plus I naught square sine square omega t plus of 2 times of I naught square sine omega t. Correct? I can say this will be the simply as first step. Correct? Now what is the second step? You always take the mean. Take the mean average. Average of I naught square will be as it is. Now here plus I naught square, average value of sine square omega t, that you have to take, plus 2 times of I naught square, average value of sine of omega t. Correct? Now it is the result where it will be coming. This will be as it is I naught square. Here it will be I naught square. Here this will be interesting. What is the average value of sine square omega t? Exactly, it is half. And what is the average value of sine omega t? This value is 0. This value is 0. That means that complete value is 0. Now check here what you will be doing. Now the final step is what? IRMS. That means you have to just apply a root. That means you will be applying a root. You will be writing I naught square plus I naught square by 2, or further you can write it as, it will become 3 I naught square by 2. Also it can be written as root under 3 by 2 times of I naught. 3 by 2 times of I naught. So it becomes very simpler. Otherwise you have to integrate it in very big integration. It will be, you can go by that method also, and I will say that go by that method also and try to solve this question by the conventional method as well. It will give you a better idea of having the depth of the questions. Okay, but still if you have to use the results, you can solve so easily that much of lengthy question. Okay. Now let's enter into the actual topic that we have to understand, that is alternating current. Now if I will tell you about the summary of this chapter, we are going to understand about lot of circuits. Firstly, we are going to understand everything is going to come into use. Resistance circuit, capacitor circuit, inductor circuit, then combinations will be coming. LR circuit, inductor and resistor circuit, LC circuit, okay, RC circuit. All these circuits are going into by simultaneously, and then finally we are going to understand also the combination of all these three circuit, LCR circuit. Okay, that combination also we are going to understand in this complete chapter. From here circuit parts get started. Okay, so I hope that you will be enjoying this portion. It is very interesting, nothing to remember, no formula, always understand from the concepts. Every topic is related. Okay, same kind of things we are going to do. We are going to represent everything in phasor and this kind of things. We will be watching the phases, how the phases will be getting changed, and what are the rest of the things. Firstly, let's understand the basics. Let's understand the basic outlines. If an AC source is connected to, it can be connected to resistor. This is the representation for inductor, and this is the representation for a capacitor. Already we know. Okay. One more thing, tell me, if I have to write the potential difference across a resistor, how I will be writing, because that is important thing, I into R. If I have to write a potential difference across inductor, how I will be writing, EMF, you remember, it is equals to L di by dt. And if I have to write a potential difference across a capacitor, how I will be writing, I will be writing Q divided by C. Because it is will be coming into use, I am going to apply KVL in lot of the places. Okay, so there will be this kind of combinations that we are going to study: LC circuit, LR circuit, LC circuit, and LCR circuit as well. All these circuits we are going to understand one by one at a time. Firstly, we are going to understand all the pure circuits. For example, let's start from the purely resistive circuit. Only a resistor will be connected, and firstly let's try to make the foundation of this chapter, that what we are going to actually discuss. It will be more easier to understand from a single circuit at a time. Then we'll be taking two at a time, and then finally we'll be taking the three combinations with all together. Okay, let's understand. Let's suppose a battery is there having the source E is equals to E naught sin omega t, and a resistor, only resistor is connected. Okay, let's apply KVL. Let's apply KVL. What you'll be writing about KVL, you'll be writing, let's suppose you are crossing this E, and then you'll be writing minus of, let's suppose any current I is flowing into this, is I into R is equals to 0. So what I can say about I can be written as E divided by R. And what I can write about E, what is the E? E is equals to E naught sine of omega t divided by R. So this can also be written as I is equals to I naught sine of omega t. Now some basic and very important things that you have to understand from here, that I is equals to I naught sine of omega t. About phases now you have to understand. What is phase? What is phase? If it is the case, this coefficient of complete sine term, this complete term is called as phase. This complete term is called as phase. If I have to write any general equation in SHM, you remember that we have written the equation is equals to y is equal to a sine of omega t plus of phi, and this complete term is called as phase. This phi is called as initial phase. This is called as initial phase. So these terms are very important. Now if I will ask you a very simple question, tell me what is the phase difference? What is the phase difference between EMF and current? What is the phase difference between EMF and current? What you will be saying, sir, what is the phase difference? I am going to discuss about phasor also, don't worry. If anyone have missed those topics, I will not let you feel that you are lacking something. I am again going to explain you how to represent anything on phasor. So what is the phase difference between EMF and current here? Can you say the phase difference delta phi is equals to 0? There is no phase difference between them, because both of them are having the same phase, omega t and omega t. Clear now? So this is the behavior of resistor circuit. In resistor circuit we have to understand current and voltage are in the same phase. As of now, just whatever I am saying, just absorb it. Very soon you will be understanding why I am saying all these things and what is the significance of all these things. Okay, as of now just keep understanding. So current I in the same phase with the potential, that is what we are understanding. Now let's understand how to represent these things. Now let's understand the phasor diagram. See, let's suppose there are two things that I have taken. EMF I have taken E naught sine of omega t, and current I have taken I naught sine of omega t plus of phi. If I will ask you, tell me what is the phase difference between them? Jaldi se batao, what is the phase difference? Phase difference, what you will be doing? This is the phase of this one, and omega t is the phase of this one. Phase difference, that means you have to take the difference. If I am taking this difference, omega t will be cancelled, and phase difference delta phi, or you can write it as phase difference is equal to how much? Phi. That means what this phase difference is reflecting, that when we are going to represent this on phasor, the angle between the current and this EMF should be equals to how much? Phi. Let's represent this also. Firstly, let's represent what is the EMF. This is taken as a reference line. This is always the angle that is equals to 0. From here all the reference that we used to take. Now tell me, what is the angle, what is the phase of EMF? Can you say it is at the angle, if I will talking about theta, this angle is omega t. So represent this at an angle of EMF, amplitude is E naught, and this angle is how much? Omega t. This angle is representing what? Omega t, let's suppose. Now represent current. What about the phase of current? Phase of current is omega t plus phi. Phase of current is what? Omega t plus phi. That means I can say that it is of course going to be greater than this. So I'll be writing what? Let's suppose this is I naught. Okay, this is I naught, and this angle is omega t plus phi, and I can say simply this term, the angle between the E naught and the current is going to be equals to how much? Phi. This is the representation of any kind of equation in phasor. I have explained the same thing in the SHM also. In SHM also we have discussed the same things. Okay. So in this case, if I am talking about current, now if I have to represent it in phasor, I can say both are in the same phase. Omega t from the reference line, that is phi is equals to 0. Both are at the same angle. Omega t is equal to 0. That's why both of them are represented on the same line. If I have to talk about a wave diagram can be represented like this. Now it depends on the amplitude. Otherwise, both of them are sinusoidal, so there is no problem into that. This is the most important thing, that again when it will be coming in combination, I am going to ask you the only three things I am going to ask you, and I will derive everything on the basis of that. Tell me what is the phase difference between current and potential in resistor, phase difference between current and the potential in capacitor, phase difference between current and voltage in inductor. Only these three questions I am going to ask you, and we are going to see all the combinations on only the basis of these three statements. Okay, so that's why I am again saying whatever I am telling you, just keep remembering that. Now let's enter into the purely inductive circuit. Let's understand what is happening in purely inductive circuit. Again I am going to apply KVL, and again EMF is given as same, E naught sine of omega t. Let's see this time what is happening with the current. So I am going to apply KVL. I will be writing, let's suppose I am crossing this, I will be writing it as E, and I am writing across this one, let's suppose I am writing minus of L di by dt is equals to 0. Then I can write E is equals to L di by dt. I can say what? L di is equals to E. E is equals to what? E naught sine of omega t into dt. E naught sine of omega t into dt. Now integrate it both the sides. Integration is going to give you what? L into I is equals to E naught, that is constant. Integration of sine omega t is going to give you what? Cos of omega t. And integration of sine of omega t also going to give you a minus sign as well. Correct? So what I can say, it can be further written as, if I want to, and I can write current is equals to, and one more thing, integration of that means the coefficient of time will also be coming. This is the complete integration by omega. So I'll be writing current will be equals to E naught divided by omega L, and I'm going to write this cos omega t in little bit of different manner. How I'm going to write? I'll be writing it as sine of omega t minus of pi by 2. I'm going to write it as I is equals to E naught sine of omega t minus of pi by 2. Clear? Now if I will be noticing this, what some very important things that you have to take from here. What are the some important things? If I will ask you, not tell me what is the phase difference between them. What is the phase difference between them? I can say who is leading and who is lagging. If I'll ask you, firstly the phase difference between them is nothing but pi by 2. This is omega t, this is omega t minus of 90. That means I can simply say it is lagging. I will say one very important thing, that potential is leading by an angle of pi by 2. This is very important line. One more very important thing, if you will be remembering the last one, it can also be written as I is equals to I naught sine of omega t minus of pi by 2. So this I naught, that means how I have written, I can say this omega L is behaving like a resistor, and actually there is a term that is defined for this. E naught is divided by, it is written as XL. What is this XL? XL is equals to omega L, and this is called as inductive inductive reactance. If I'm talking about the units are also going to be ohm. It is same as ohm. The units, there is no change in the units of this inductive reactance. It is same, equals to ohm. That is the unit that we are going to use. So I hope that this much of the things are clear. If I have to represent this on phase diagram, how will be representing? I will firstly represent EMF. What is the phase of EMF? Check. Phase is omega t. So from the reference level, I will represent EMF at some angle of omega t. Now if I have to represent the current, how I will represent? It is what? Omega t minus of pi by 2. That means from this omega t, it is lagging by an angle of pi by 2. That means somewhere here your current will be there, and it is lagging by how much of angle? It is lagging by an angle of pi by 2. Is it clear? The most important line that we have to remember is this one. Potential is leading by an angle of pi by 2. Okay. See, this is what I have explained you, that this omega L will be written as XL, and this XL is equals to, it is called as inductive reactance, and the unit will be same as it is as the resistance, that is ohm, and the behavior will also be same, the work will also be same. It is just called as inductive reactance. Okay, I've told you that if I have to represent the phase diagram means what? If this is the representation for E naught, this I naught is lagging by an angle of how much? Pi by 2. Here you can see the angle between them is pi by 2, and here you will be saying that current lags by a potential of 90 degree. Correct? Now come to purely but before that there is a question. Let's try to solve this question so that it will clear your basic doubts that you will be having. Okay, see, you have to find I average and I RMS of the given circuit. You have to calculate I average and I RMS of the given circuit. The circuit that is given is here. EMF is given somewhat like this. EMF is, the general equation is given as 10 sine of 10t plus of how much this angle is given. Let's see, let's suppose 5. Anyways, I don't think so that will be coming into use. So what you have to calculate? I average. For any circuit, what is the I average? Simply it is going to be 0. That means this option is anyways incorrect. This option is also incorrect. Only option A and C are left. If I have to calculate I RMS, how will be calculating? I will be writing I naught by root 2. I will be calculating I naught by root 2. Firstly, let's calculate what is I naught. I naught can be written as E naught divided by the resistance, and it is a kind of inductive circuit. That means at the place of resistance, what I have to write? There is no resistor connected, there is an inductor connected. That means I have to write it as XL. E naught divided by, it can be written as omega. This is a very good application. Okay, so E naught, tell me what is the value of a peak EMF? Can you say it is nothing but equals to 10 divided by omega? What is the omega? If we compare from these two equations, omega will be equals to 10 into what is the inductor? That is equals to 2. Cancel. That means I can say this is coming a half ampere, 0.5 ampere. Which option is coming correct? Sorry, this is I naught. This is I naught. If I have to calculate I RMS, because I have to calculate I RMS, that will be equals to I naught divided by root 2. That can be written as 0.5 divided by root 2. 0.5 divided by root 2. That means option C is definitely correct. Is it clear? There was no resistance given, but we have checked, we have seen that due to inductor also there is some behavior of resistance, and that behavior is called as inductive reactance. Okay, and we have seen that also how to apply the formulas and rest of the things. Is it clear? See, correct answer 0.5 divided by root 2. Clear? Now let's come to the purely capacitive circuit. Let's understand this purely capacitive circuit as well. Again we are going to apply KVL. How I am going to apply KVL? Again I am going to jump across this battery, that will be giving me E minus of Q by C, because I know that the potential difference across a capacitor is written as Q divided by C. I hope that this much of basics you will be understanding. Now again write what you can write for it is equals to 0. Again try to solve it. When you will be solving it, E can be written as E is equals to Q by C. That means Q can be written as what? E into C. And what is E? E is equals to E naught C sine of omega t. EMF is same. it is equals to Q. But I want to check what is the about the relation between EMF and current. So how I will be getting? I know that if I will be differentiating, because current is equals to what? dq by dt. That means if I will differentiate this charge term, that is with respect to time, I will getting my current, correct? So now differentiate it. What will be writing? dq by dt is equals to E naught C into sine of omega t. You will be getting differentiation cos of omega t. Cos of omega t, and there is a differentiation term. That means you will be getting what? Chain rule, you will be getting omega as well. So now it can be rewritten as current is equals to E naught into omega into C, and it can be cos of omega t can be written as, I will be writing it as in different manner, plus of sine of omega t plus of pi by 2, sine of omega t plus of pi by 2. Now see, so I will further write this equation. I is equals to E naught divided by 1 by omega c into sine of omega t plus of pi by 2. Now you tell me in the comment section what are the things that you will be noticing from here. Same kind of thing we are doing for the third time now. We are doing for the third time. See, first thing, I can write this also, this complete term as I naught. That is what I can say about this term. This term is behaving like again like a resistance, but this time resistor is not connected. Who is connected? Capacitor is connected. If capacitor is connected, it will be called as, this complete term is called as E naught divided by, it is written as XC. XC is equals to what? 1 by omega C. 1 by omega C. That is what we have written here, and this is called as what? Capacitive reactance. This is called as what? Capacitive reactance. This is the first important thing. Now what is the phase difference between both of these? Phase difference between EMF and current, I can say it is equals to pi by 2. This is one more very obvious thing. What is the phase difference between both of them? That is equals to pi by 2. And if I will ask you who is leading, who is lagging, so the most important line now, that is what I am summarizing here. The most important thing that you have to understand here, I will say, here I am writing the most important line, that current is leading EMF by a phase difference of pi by 2. Phase difference of pi by 2. Now let's again take a quick recap. Resistor, what about the phase difference? EMF and current both are in the same phase. Capacitor, current is leading by a phase angle of pi by 2. What about inductor? Inductor current is lagging. It is not leading, it is lagging by an angle of pi by 2. These three statements are the most important one, that in which kind of circuit who is leading. In resistor, same phase. In inductor, current is lagging. Always remember for current, simultaneously understand for potential also. And in capacitor, current is leading by an angle of pi by 2. Correct. Now when the combinations will be coming, it will depend who is in majority. If inductor is in majority, then current will be lagging, not by pi by 2, but it will be lagging by some angle. When we'll be discussing about if the capacitor is majority in combination circuits, that means at that point of time current will be leading by some angle. We will come to that case also. So I hope that till now it was very much clear to you about all these three circuits, pure circuits that we have represented here. This is the important term, XC is equal to 1 by omega C, and the SI unit will be again ohms. I have told you, if I have to represent the phase diagram, I will be representing E naught here at some angle omega t, and I will be representing I naught pi by 2 angle ahead of it, because the phase difference, current is leading this time by an angle of pi by 2. That is the same representation. This is the summary of whatever you have understood till now. Now after that, solve a basic question. Current in a pure capacitive circuit of C is equals to given somewhat like, see, capacitor is given as 5 microfarad. Okay, most of the time calculation is in microfarads. This is a general equation of current. That means I is equals to I naught sine of omega t plus of 30 degree. The question is asking you find the equation of EMF. Find the equation of EMF. Okay, very fine. So if I have to calculate EMF, what is the general equation of EMF? I will say if it is a capacitive circuit, that means EMF is lagging by a phase angle of
pi by 2. That means what I will be writing? I will be writing E is equals to E naught sine of omega t that is 50t plus of 30 that is already given. I can say if I have to write the phase difference, what is the phase difference? 90, but it is what? Lagging by an angle of 90 degree, lagging. That means I have to subtract it by minus of 90 as well. That means now check the options only. Here it will be a term of minus of 60. Minus of 60 is correct. Initially only I can say option B is only going to be correct. From the very basic, still we are going to calculate it completely. So what I can say about E naught can be written as I naught into, resistor is not there, capacitor is there, and what is the effect of capacitor? We write it is equals to XC, that is capacitive reactance. I naught is how much? 5 into XC can be written as 1 by omega C, 1 by omega. Omega is equals to 50 and C is equals to 5 into 10 power minus of 6. Further, if you are solving this will be written as 5 cancel. Here it will be 10 power 5 divided by 1 by 5, that means it can be written as 0.2, that means it can be further written as 2 into 10 power 4, that is the value of E naught. Just put the value of E naught here. 2 into 10 power 4 sine of 50t minus of 60 degree. Option B will be correct. Is it clear? If any doubt, then tell me in the comment section. Okay, we'll be taking your doubts. I hope that this will be clear. We have applied the concept of who is leading, who is lagging. Okay, fine. So this, till now we have understood all the circuits in single manner. Okay, individually we have checked for capacitor. Sorry. Individually we have checked for capacitor, individually we have checked for inductor, individually we have checked for resistor. Now in the next class, what we are going to understand, combination of resistance and capacitance, combination of inductor and resistance, combination of all these three. Then we'll be talking about power and the rest of the things. Then we'll also see some things, quality factor and bandwidth. All these things we are going to understand. And then finally the next topic, and then the very important thing, that in the last chapter I have told you I am going to tell you about transformers. Now in this chapter at the end there is some little bit one or two formulas that are there in transformers. We are going to discuss that as well. Okay, so until next time, keep learning, keep going with Tapasya, Endigu and then Digu Nama Tapasya.